Hey everyone, welcome to my channel. In this video, we are going to create an object classifier that can classify any objects that we feed in. So in this particular case, we will be using Arduino, Raspberry Pi, and Jetson Nano. So we will classify between these three and see how well it performs. Now we will be writing the Python code and we will be using an online platform called Teachable to actually train the system. So you don't have to write a lot of code. And for testing, the code that we will write will be pretty much around 10 to 15 lines at max. So without spending hours and hours on training and testing, we will be able to get our classification model up and running within just a few minutes. So let's get started. So the first thing we will do here is to go to Teachable Machine. So this is provided by Google. You can Google Teachable Machine or you can write teachablemachine.withgoogle.com. This actually allows us to create our classification models and then we can simply download them and use it in our Python project. So what we can do is we can click on Get Started. So here we will select the image project, and for this project we are going to go with the standard model with 200 pixel images. So here we have a couple of options. What we can do is we can upload our files and then we can also use our webcam. Now, if you have seen my previous video on mask detection, where we had a gun shooting whoever didn't wear a mask. So in that case, I actually used my own data set. By that, I mean I uploaded my files and I captured the files using a Python script and then I uploaded it here so that it is in a similar scenario when it's testing or when we are utilizing it. But in this case, we can directly get it from the webcam because I have set up my webcam here and we can bring in our Raspberry Pi and Arduino and see how well it performs. So here we can add through a webcam and we can select the webcam that you have connected. So here you can see my table, and what I can do is I can bring in the Raspberry Pi, and what I will do is I will start recording by pressing the hold to record button. So there you go. So this is an old Raspberry Pi. We can bring in the new one as well. But for this example, I think this should be fine. We just want to see how it performs. So we will take about 300 images for each. So now that we have these 300 images, we will go on to Arduino. So here, first of all, we will name our class Raspberry Pi. So take a note of the name that you are writing here because this is the exact name that will appear on the result. So whatever name you want, write it correctly over here. And then in the labels, automatically, it will classify and give you the output with the name. Okay, so then we will do the Arduino. So let's write here Arduino. And we will use the webcam again. We will switch. And there you go. So a little bit in, out, rotated. So okay, so we have around 300 images of these as well. So let's go ahead and train this. Now you do have some options to actually change the epochs or the batch size or the learning rate. So I would recommend to keep it at default if you don't know a lot about this. So if you do, go ahead and feel free to change these parameters. So we will click on the training part, the training button, and it will start preparing the data. And you will be surprised how quickly this works. So I'm not going to pause or I'm not going to go forward. You will see how quickly this finishes as it is. So here you can see it is training and it is going for 50 epochs. So that's why you have here 50. So this is 30, 32. So it's almost about to finish in less than a minute or even half a minute. And there you go. So the model is now trained and we can switch our webcam. So this is the testing part. We can also add files. We will actually try with the files as well, just in a short moment. So let's go ahead and try it out. So right now it's saying Raspberry Pi because we didn't set any default values. So, sorry, the default class. So that's why it is giving a Raspberry Pi. So it will give one of them by default. So let's try the Arduino first. There we go. So it is detecting the Arduino. And then let's try the Raspberry Pi. There we go. So it is detecting the Raspberry Pi. This one I think is Raspberry Pi 2. Yeah, Raspberry Pi 2. It's a really old one. Anyways, now if I wanted to add another class, I would simply click on add a class. And here I will write Jetson Nano. And we are going to use the webcam again to add our okay, I have a fan on top of this which might interfere. Maybe I should remove it. Let's remove it. Okay, so I have removed the fan now, and we can go ahead and take the samples. So I will press, okay, this one is a little bit bigger than the other two. So let's hold and record. So we have about 300 samples now. And what we can do is, so we already have a trained model, but what we need to do is we need to add this new class. So we will have to train it again. So again, it doesn't take a long time, so it shouldn't be that difficult. So let's train it. So now we have our third class training as well. By the way, you can see the images here. So you can see the samples that you have taken. You can scroll horizontally to actually see. And the idea of classification is that you are detecting the complete image as an object. So it's not part of the image, it should be the complete image. So if the object is very far away, it will not detect it properly. And in a lot of cases, what you can do is you can find the contours and you can find where the object is. And based on that, you can say, okay, this region I want to classify. So we will see that, and I will share with you how I did the, the mask project. So in the next video, we will look at how we can detect the face and then how we can classify whether it's wearing a mask or not. So we will look at that as well. So now it is trained, and now we can bring in the Jetson Nano, and you can see it detects it as Jetson Nano. So that is pretty good. We bring in the Arduino. Okay, it's confused. Okay, so if it goes too close, it won't be able to classify properly. As I said, it has to be the whole image. So here, when it is visible completely, then it is very sure that it is Arduino. And then if we go back, you can see the Raspberry Pi. Again, if you zoom in, it might be flickering because it's not sure. So next we can try out some images. So I will go to Google and I will search for some images. So here you can see we have a few images. So let's take this one. Let's save it on the desktop. And let's search for another image. Then let's go and search for Arduino. And we can get this one. Okay. And let's get another one. Let's say this one. This one might not detect it properly because it's angled, but let's see. It will be interesting to see if it works or not. Okay, then we have Jetson Nano. Okay, Jetson Nano, let's take this image. And let's take, let's say this one. So we are trying 2 images for each of these. And we will see how it performs. Okay, I will put it on the side, and I have all the images on the desktop, which is not a very good practice. But anyways, what we can do is we can simply change this to file and we can drag it in. So let's drag in the Raspberry Pi, and there you go. It's 100% sure that it's Raspberry Pi. Let's try the other one. It's 99% sure. That's very good. Let's try the Arduino. Okay, so this one, it got it wrong. It thinks that it's Jetson Nano. Let's try the third one. Oh, it's very sure that it's Jetson Nano. So the Arduino is not working properly, And then we have the Jetson Nano, and then the Jetson Nano is good. Okay, let's go ahead and try some more images for Arduino. Maybe we can take top views. Maybe it will be better. Let's try maybe this one. So the thing is, what we did was we trained the model in less than 1 minute, and we quickly added some data set that we had. So it will not be very useful in all cases. So like, for example, in Arduino, it's not very accurate when it's from a file because of the background or because of the lighting. It can be anything. So what we have to do is we have to add as much data as we can so that our model is very robust. But I believe if we go to our webcam, it should detect the Arduino properly as well. So let's try it here. So there you go. So it is detecting Arduino properly if it's like this, but through the images it's not. So that is a good way to test if your model is working properly or not. So what you can do is you can add more images, and you can add more different types of backgrounds. You can even remove the background and then take the images, something like that. So that's why sometimes it's better to do the images using a Python script and then bring it in to upload. Anyways, so for now, I think we are done. And what we will do is we will export our model. We will click on export, and then we are going to go to TensorFlow, and we will download the Keras model. So we will click on download model. Now you don't need to worry about this code. We have already created a module out of this, and you can simply import it and run it. So you don't need to go into the details of how this works. But if you want, of course, you can go through. They have given these comments that are very helpful. So it might take a while because it will convert the model and then it will download. Okay, so it is downloaded, and you can see here that we have two files, kerasmodel.h5 and we have labels.txt. So we will be needing both of these files because label.txt has the names of your classes, and then the Keras model is actually the model that will help us find or classify our objects. So let's go ahead and open up a new project in Pycharm. So now we are in our Pycharm, and we are going to create a project. We can call it classification model test. So now our project is opened up, and the first thing we will do is we can delete, let's just delete this, and we will keep the main file, and we will go to file settings, and here we are going to add our packages. So we'll go to projects, Python interpreter, and we will add. So here the most important packages that we need are CVZone. We will install that. Now this here is 1.3.2. So any version above this, or at least this version. If you go below this, it will not work. It will be this version or above this. So let's install that. And then we also need TensorFlow. So that is the library that will help us classify. So we will hit install. I'm using the version 2.5.0. So it depends. If you have a later version, you can use that as well. But at any given point, if it doesn't work, you can come back to these versions. And I'm using Python 3.7.6. So if you are using a later version and it doesn't work for you, come back to Python 3.7.6. You can always find it in the archives on the Python website. So you can download and install that. So let's wait for the TensorFlow to actually install. It is a very big library, and it requires a lot of different libraries as well. So right now we have just installed CVZone that automatically installs OpenCV and NumPy. So these are the two main libraries that we will be needing. But other than that, we will be also needing the TensorFlow, and it will install a lot of libraries. You will see it will be filled up just in a moment. But it is quite big, so it will take a while. So we will wait for it to install and then we will come back. Okay, so now TensorFlow is installed and we can hit OK. So the first thing we will do is we will import our packages. So we will write here import CVZone, and then we will write import CV2. Then we are going to create our video object. So we will write here cap is equals to CV2 dot video capture, and we are going to give in the ID number 0. So this is the camera number, and then we are going to create our classifier. Now you can call this anything you want. For now we can just call it my classifier. So this classifying class actually belongs to CVZone. So you can write here CVZone dot classifier. So what this will do is it will take in an image and it will classify which object does it belong to. But for that to work, we need to give it a model path and we need to give it a labels path. So what I like to do is, this is up to you if you want to do it this way. What I do is I go to show in Explorer, and here I like to create a new folder and I call it my model. Then we will bring in our model files that we downloaded from the Teachable website. So these are the two files. We are going to drag them in. So these two will be here. We will not change the names. We will keep them the same. And then here you will see now my model has appeared. So you can write here my model slash, and then you have to write this name. So we will write here Kiras underscore model dot h5. And then for the labels, we have to do the same. We have to write my model, and then we have to write labels.txt. Labels should be E here. Okay. So just to make sure that everything is working fine, we can just right click and run. And if it doesn't give us any error and it exits, it means it is working fine. So these are just warnings and I don't see any errors. So it should be fine. Okay, then the next thing we have to do is we have to create our while loop. So we will write here while true, and then we are going to get in our image using the cap.read, and then we are going to ask our classifier to classify our object or to classify our image. So what we can write here, let's say these are the predictions is equals to our classifier, my classifier dot get prediction, and all we have to do is we have to send in our image. Now there are a lot of other parameters, but for now the least that is required is the image. So we will just write in that, and then we will write here cv2.imshow, and we are going to write here, let's say image, and we want to display our original image. And then we will write cv2.waitKey, and we will give in 1. So that should be fine. So let's go ahead and run this. Okay, we are getting an error. So mostly when you get this 215 error, it is because the image is empty. So probably the camera ID is not 0. So let's try another one. Let's try 1. Yeah, so now it is working, but it is not the correct camera. Oh, okay, I think I get the problem. In Teachable Machine, you can see here it gives us a red dot. It means it is using the webcam. So we need to close this, or we need to at least disable the webcam so it doesn't use it. Yeah, there you go. So now it's not showing that red dot. So if we go back and write 0 here, it should run the webcam. Okay, so now it's working. and it is giving us the output that it thinks. As I mentioned before, it will give us a default value. So let's try out with Arduino. There you go. It says Arduino. And then let's try Jetson Nano. It says Jetson Nano, excellent. Let's try out Raspberry Pi. It is going to say Raspberry Pi. Again, Arduino. Arduino is a little bit tricky. Still thinks it's Raspberry Pi. Okay, we have to go back a lot. And it is confused between Arduino and Jetson Nano a bit. So again, you need to train it a little bit more. So now we are able to write on our image which of the objects was detected, but we need to know the actual values to actually use them in some projects. So the idea is that it is actually returned back in the predictions, and the classifier actually returns two things. So we have to write here index as well. So it will give you the index of the class detected, and it will give you all the predictions that it found. So it will contain all the probabilities. So what we can do is we can simply print here the predictions, and let's run that. So there you go. So at the bottom here, you can see that these are all the predictions that we are getting. So right now it's saying Raspberry Pi. Let's bring in the Jetson Nano. So when we bring in the Nano, you can see this goes to 0.999, which is almost 1. So it is almost 100% sure that this is Jetson Nano. And the index is 2. So the index, we are getting it here. So we can print that too. So we can write here index, and we can print that. So there you go. So the index is 2 now. If I remove it, it goes to 0. And if I bring in Arduino, again, it's not detecting very well. The Arduino, let's put it straight. No, we need more data for Arduino, but we can see for Raspberry Pi and Jetson Nano, it is detecting as 2, and then it is detecting as 0. So there you go. So this is basically the idea of how you can create your own classification model. And if you want to check the frame rate, you can simply write here FPS reader CVZone dot FPS, and then at the bottom here you can write FPS reader dot update, and we don't need the result, so we just can input an image on which it will draw, or we can let's not draw, let's write it here. We need the FPS, and the second parameter we are going to ignore. Do we have, yeah, so let's print that out, print FPS, and let's see what do we get, and we can remove this part. Oh, I think it's only FPS, my bad. So if we are inputting an image, then we will get an image output. But if you're not inputting any image, we will only get the number. There you go. So we are getting around 14-15 frames per second. So this is how fast it can perform. Again, this model is a little bit heavy. So that's why they also have the option of a lighter model on their websites. So 14-15 frame rate is a decent frame rate. It's not that it's completely unusable, but in real-time applications, it might not be the best, but in a lot of different scenarios, it should work fine. So you could even write the FPS on the image. So as I mentioned, you can write the image, and you can return the image from here. And here you have some parameters that you can give. I believe you can give the position of the, what do you call, the placement. So here you can write, let's say 20, and then say 150. 150 might be too much, but let's try it out. Yeah, 150 is too much. So we can push it up a little bit. Maybe 100, and this is too big. The prediction it's drawing on the image is too big, so there is an option for scale. Scale, we can reduce it to 1.5, let's say. So it's not that big. There you go. So now we are getting a smaller, let's put it as 1, and let's push this let's push this to 50. Let's push this to, it is 640, so let's say 575, or that might be too low, so 550 maybe. Yeah, it's going outside, so we can write here, let's say 450. Yeah, there you go. So now we are getting a better image that is giving us all the information that we need. So there you go. So this is it for today's video. I hope you have learned something new. I hope you will use this in a lot of different projects, and let me know how that goes for you. And if you haven't subscribed, do subscribe and hit the like button, and I will see you in the next video.